today we'll be discussing about Bitwise operators. Bitwise operator is one of the most important topic, especially when it comes to the embedded system microcontrollers. Correct? I know that the topic is long enough and we may not be able to justify the entire topic in a day. However, we will try to start with some foundations today, and we will try to progress further considering few more topics into it. So here we begin, and the first thing that we want to discuss today is bitwise operators, and which all bitwise operators are there in C language, right? So what we are saying is that the C programming language has got six bitwise operators. Six bitwise operators. So these six bitwise operators, first one is called as a bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, bitwise left shift, and bitwise right shift. So these are total six operators we have. We will definitely discuss what these six operators are and how these operators work together in a step-by-step manner. Right. But very first thing that comes to my mind when I see that bitwise and bitwise OR and bitwise NOT is I have also seen there is something called as a logical AND, logical OR, and logical NOT, right? So the question is, what makes it different? How bitwise operators are different than the logical operators, right? So, so this is like a first thing we will try to take a look at. As I told you already, there are three logical operators as well. First and foremost difference that you see is that this is written as a single ampersand while this is written as a double ampersand. Correct? This is written as a single OR while this is like a double one. And not sign is probably entirely different. It's a tilde sign while this is like an exclamation mark. So these are the logical operators. So what is basically the difference? The basically difference is that the logical operator operate on a value. The value in terms of true and false. I hope you know that in C language, true is any non-zero number and false is nothing but zero. Or other way around, you say that any non-zero number represents true while a zero number represents false, right? Bitwise operators operate on the individual bits, so they are not operating on a whole value of a number, rather they are operating on each bit of a number. I hope you are getting the point. Going a step ahead, the logical operator result is always either true or false. So logical operator result will be either 1 or 0. However, bitwise operator result will be a numeric value coming from that particular bit manipulation. So like a first difference that we should be knowing, that bitwise operator and logical operator. I quickly revise. The logical operators talk in terms of true and false, zero and non-zero. Bitwise operators go through the individual bit of the number and operate there, right? So now it's time that we'll go ahead and discuss the each operator in short. Correct? What bitwise AND operator is, what bitwise OR operator is, what bitwise NOT operator is, XOR operator is, and then probably left shift and right shift. Correct? So going ahead, talking about bitwise AND operator. The bitwise AND operator is something similar to the electronics logic gates. So logic gates, we say that there are logical AND gate, there is logical OR gate, there is logical NOT gate, and also there is XOR gates. So again, these are probably derived from something similar. Or if you have ever come from a kind of a mathematics background, you might be able to see it in terms of the Boolean algebra. Correct? So let us just quickly go back and quickly try to understand what is speciality of bitwise AND operator. The bitwise AND operator works on two operands and produce the result. Please note that if any one bit is 0, the resultant bits will be 0. So what you find it over here is that over here any one bit is 0, the resultant bit is 0. Over here one bit is 0, the result is 0. Another bit is 0, result is 0. The result will be 1 if and only if both bits are 1. Do take care of it. It is bitwise AND operator. Going a step ahead, you also understand that if you have got any bit and ended with 0, the result will be always 0. At the same time, if you AND any bit with 1, the result will be that bit itself. What I'm saying is that if the bit is 1 and you ended with 1, the result is going to be 1, which is same as x. And if it is 0 ended with 1, again the result will be 0. Right? So, you are understanding it? Going ahead, how these bitwise operators are actually utilized in a program. So here is a small program that you are able to see, and purposefully to keep it simple I'm dealing with the character numbers, character values. Why character values? Because you know that the size of character is 8 bits, right? Since it is a 8-bit size, so drawing 8 bits on paper becomes very easy. Definitely you can extend this for the short values or int values as well, but you need to keep in mind that they are not limited to the 8 bits. You need to go with the 16 bit and 32 bits respectively, right? Going ahead, so first one is, let's say, 9, and second number is 5. So 9's bitwise pattern, I believe you people know that, and 5's bitwise pattern is again 101. Doing a AND operation, bitwise ANDing operation, what we can do is that we need to just go it bit by bit. So as truth table is already in front of you, we can discuss 1 1, that gives me the last bit. I'm talking about LSB, that is 1. 0 0 will yield 0, 0 1 will yield 0, 1 0 will again yield 0, and rest of the bits, as you are seeing, they will be always 0. What this number is? Oh, this number is nothing but 1. I hope you will be able to see that the C will be equal to 1. You can try to print it. This is a quick introduction what is bitwise AND. We can go a step ahead. As you understood bitwise AND, let us quickly talk about how bitwise OR come into picture, right? So going ahead, bitwise OR, take a look at the truth table once again. Bitwise OR says that if any one bit is 1, then the result will be 1. Again, it operates on 2 bits and produce the result. Here both the bits are 0, so result is 0. Here one bit is 1, result is 1. Here one bit is 1, result is 1. And obviously both bits are 1, result is 1. What do we understand with this? What we understand is that if you OR any bit with x, then the result will be always 1. And if you OR any bit with 0, the result will be same bit. That is 0 odd with 0 will remain 0, but 1 odd with 0 will become 1. Correct? Let us take same numbers once again, and we can quickly try it with 9 and 5 how bitwise ORing works, right? So again, this is 9's bitwise pattern, this is 5's bitwise pattern, and let us go bit by bit from LSB. So 1 1 is 1, 0 0 is 0, 0 1 is again 1, 1 0 will be again 1, and then again you have got 0 0 0 0. And what this number is, I believe that this number is 13. So if you try to print it, you should be able to see the number 13 over there, right? So you can definitely, a small program, you can always go ahead and you can give a try with this, right? So moving a step ahead, we talk about bitwise AND, we talk about bitwise OR. Let us go ahead and talk about bitwise XOR, which is bit different. What is different in bitwise XOR? Again, bitwise XOR also works on 2 operands and produces the result. The speciality is that when both bits are same, the result will be 0. And if the bits are different, x and x bar probably, which is saying that negation, at that time the result will be 1. Correct? So you find it wherever it is 0 0, result is 0. Wherever it is 1 1, result is again 0. However, when it is 0 1, result is 1. When it is 1 0, result is 1. Right? That is correct. And again, you want to try it, that how exactly it goes with our numbers 9 and 5 once again. So let me just try the XOR operation. 1 1, I guess it becomes 0, same bits. 0 0, again it is 0. 0 1 is 1, and 1 0 is again 1. Rest of the bits I set them 0. Right? And what this number is? Oh, this number is 12, where you find the result will be 12. Correct? So far we discuss bitwise and bitwise or and bitwise XOR. Please note that all these operators were working on two operands. Now here is a small change. The next operator that we are trying to discuss is a bitwise not operator. And bitwise not operator, right? And bitwise not operators, I'm expecting that it is bit different. What is different into that? The difference is that it is not working on two operands, rather it is working on a single operand. So we say that it is a unary operator and produce the result. And what is that? It is just producing a complement. Means if it is 0, it will become 1, and if it is 1, it will become 0. So nothing much we need to think of, and nothing much we need to discuss about. So what we simply say is that you start with the number 9, so which is a bitwise pattern, and making complement makes it very easy. What? Wherever you have got 1, you make it 0. Wherever you have got 0, you make it 1. 0, again you make it 1. 1, again you make it 0. And again, since all these zeros are there, it is all ones. But I hope now this number is rather the bigger one. Correct? So what this number is, purposefully I not try to print it with %d, but try to print it with %x, out of which a is pretty clear, it is still 9. But what about c? What c number is will be printed? Please note, in a hexadecimal I say that this is going to be f, while this is going to be 6. So you can expect the output as f6. These are the basic operators. And this is where the real trouble of the bitwise operator starts, with a negative numbers. So far, if you have noted, in earlier all examples I have used the unsigned characters, unsigned characters, unsigned characters. But in this example I just talked about a character, because I want to go ahead and start discussing something, how negative numbers, how signed and unsigned work differently. I hope you are ready. We will carry on. So trying to understand. Meanwhile, I'm expecting that you might be having some sort of questions. If you have any questions, feel free to post on a live chat. We will try to answer it. Right? Thank you. So continuing further, the signed and unsigned number. Let us understand how the signed and unsigned numbers basically stored. And there are like some misbeliefs. I will try to address them first, and then I will go ahead. I'm very sure many of you might have heard that the MSB, the most significant bit, the last, or you say the leftmost bit, the most significant bit represents sign of number. Is it true? Yes, it is true. But trust me, it is half truth. There are many other things that we do not consider. Like for example, if I consider a number to be 11, see it carefully. If I consider a number to be 11, 8-bit number, how 11 will be written as 0000, and you can say that 1011. So considering this fact that MSB represent the sign bit, usually the people consider that -11 is all about changing the sign bit only. And they try to make it like this: 1 0 0 0 1 0 1 1, and then they start believing that whatever number that they have formed is -11. But is it really -11? No, it is not. This is wrong. Then what exactly the significance of this statement? As I said that this statement is a half truth. Let me go ahead and try to write a full truth. Let me tell you that the negative numbers are stored in 2's complement form. Please note, it is not only about changing the sign. It is not only about changing a sign, but it is 2's complement form. By the way, what is 2's complement? The 2's complement is simply, you say 1's complement plus 1. I put a formula. So I say that 2's complement of any number is equal to 1's complement plus 1. Please note, it is addition. So how exactly I can do it with 11? Let us try it once again. So 11 0 0 0 0, correct? It is like 1 0 1 1. This is what I see the number. The complement of 11, please note, it is not minus, it is complement of 11 will be, it is negating each bit: 1 1 1 0 1 0 0, and then go ahead, put a plus on that, plus 1. As you do the addition, plus 1 onto that. So with plus 1 you'll find the new number to be 1 0 1 0 and all ones. What is this? This number is rightly representing negative 11, or say -11. Please do understand, this is very important. People might have a question, but sir, why negative numbers are stored in 2's complement form? If you ever want to understand this, then somewhere you need to go into the basics of electronics, basics of digital electronics. In a digital electronics, we say that the addition or the is nothing but subtraction is nothing but addition with 2's complement. What is that? It is subtraction is nothing but addition with 2's complement. So typical electronics, full adder circuit, people design to do addition subtraction both, keeping this in mind. And that is the reason on all platforms, on all architectures, you will find that negative numbers are stored in the 2's complement form. You need to always keep in mind. There's one more question that usually stuck my mind. As you see that the -11 is going to be this, don't you also think that there will be definitely some number which is also, I would say that some unsigned number which is also having the same, behavior? Yes, definitely there will be. So, a quick trial, if you just want, we can, go on to the Excel and try to do the good quick calculation, not wasting our time onto this. So we just seen a number 1101, and what we say is that this number was, I'm just converting from binary to decimal, so I can quickly find that, oh, it is, no, sorry, my mistake. I was talking about 1011. I was talking about 11. So is the number, but the resulting number that I have seen, the resulting number that I have seen is like 4 times 1 0 1 0 1. So 4 times 1, I'm going back, 4 times 1 0 1 0 1. And what this number is, you can just quickly try it. This number is 245. Please note, -11 and 245 both have same bit pattern. I repeat once again, -11 and 245 both have same bit pattern. Please make a note somewhere. So people might have a question, then sir, how computer understand whether it is signed, whether it is unsigned? And this is where your data types come into picture. Whether you give your data type as a signed number, whether you have keep your data types as an unsigned number. If you have kept your data types as a signed number, your computer try to treat it as -11, while if you declare it like unsigned char, it will try to consider it as 245. You might be wondering what is so special with 245. Okay, what is so special with 245? Let me just tell you that as well. Again, please note, purposefully I'm spending bit time onto the negative number because that is the most crucial and complicated stuff. As we go ahead with the right shift operator, you will realize that right shift operator behaves differently with signed number and unsigned number. So if you are not clear with the negative numbers, I guess it will be a trouble. Correct? So stay tuned. We are talking about. So we have got -11 and 245. I was trying to tell you what is so special into the 245, right? Please take a look at. So you find that if it is a 8-bit number, for any 8-bit number, if you are talking about, it is maximum. It can be 2 raised to 8 comes out to be 256. To be precise, it is 0 to 255, right? 0 to 255. What do you find? The number was 11. Have you ever just checked that 256 256 minus 11 comes out to be 245? Please note, it is still a -11 representation from 256, right? So for any given number, you can always do the calculation. Correct? So how you can always try to guess that if the number is 11 and you are looking for -11, what will be the corresponding new number? So corresponding new number you can quickly calculate with 256 is equal to 256 minus 11, that comes out to be 245. So instead of going on a bitwise pattern and doing the calculation, this quick trick might help you for solving some aptitude kind of questions, right? So, going one more step ahead, as we are discussing about 2's complement, there are few more things that I want to bring to your notice. As we are talking about as 2's complement, we already said that minus x is nothing but complement of x plus 1. Minus x is nothing but complement of x plus 1. So you can just try to reorganize it, and you will also understand that complement of x is nothing but minus x minus 1. Now, what is the meaning of this? It simply means that if you are taking a number 11, and you are trying to find out a complement of 11, a complement of 11 would be a complement of 11 will be minus 11 minus 1, and that comes out to be minus 12. So what again I'm trying to tell you is that complement of 11 and minus 12 both are same as far as bit patterns are concerned. I hope you can try with little more examples and you will appreciate this fact, right? We will go on to one more step ahead and take a quick example of how these negative numbers are dealt with. Correct? Let us take one small example and talk about when we have, let's say, minus 9 number, that minus 9 number, how we can try a not operation on that and will come up with the result. Correct? So for that, first you need to find out what is a bit pattern of minus 9. Just now with the previous one, you might have understood that bit pattern of -9 we can quickly find out by taking a complement and all that. Let me just quickly do that. So complement of 9 will be 11110110, right? And then plus 1 on the top of it should give me 111011, and what is the result? This result is nothing but -9 as 2's complement. Correct? So this is something in front of you. So you find that what is the a that you try to put in is nothing but -9. So minus 9 is like this. -9 will be like f and 7. And what about complement of this? So complement of -9 will be, I'll just make it 0 0 0 0 1 0 0 0, and that comes out to be, I guess, 8, and you'll find that this is 8. I believe in today's session you must have got hold on what is negative numbers and what are the basic operators, basic bitwise and operator, basic bitwise or operator, bitwise XOR operator, and bitwise not operator, right? There are even the advanced topics talking about left shift and right shift, but as I said that unless and until you are not clear with how negative numbers deal with, it is a bit complicated to discuss about the right shift operator. So what I suggest is that we should stop over here for today's session, correct? And you practice it with positive numbers as well as negative numbers for bitwise and for bitwise or bitwise XOR and bitwise not. Understand the difference between signed and unsigned well, and then we can come up and discuss with the left shift operator and right shift operator by tomorrow. Thank you very much.